So welcome to the session, We Hate Code. I guess most of you are Java developers, I hope. Okay. My name is Gerrit Grunwald. I'm working for Azul, as you can see. We do JVMs. That should be enough about me. I have some questions for you. Build now, fix later. Probably most of you heard that in one or another project, right? So we have some deadlines that we have to match, and then your manager comes in, yeah, just build it. We will fix it later, no problem. And then later means never, right? This is something that we all know, which is not a good thing. And the next thing is, who loves to maintain bad code? Probably no one. I mean, the first thing leads to exactly this, right? And this usually is the stuff that you go into a project and then you see some code and it's like, what's going on? And then you would like to change it and someone says, don't touch it. It's there forever, it works, just don't do it, right? And if you have juniors, they sometimes say, oh, look, I refactored everything, it's completely new. And then the seniors say, are you crazy? Don't do it, don't touch that code, right? So yeah, we know this stuff. So when I say bad code, I have some stats that I found on the internet quite interesting. So dealing with bad code, and when I say bad code, I mean like legacy code or dead code, stuff like that. Then if you deal 4 hours a week with that, there's a study that figured out that this is the cost, that it is annually. So it's $85 billion just by if developers work 4 hours a week on that code. Usually I now ask who's working on maintaining code here, but I can't see it. You don't have to raise your hands, so it's all good. And another one is, you can check it out here. There's a link, which is interesting. I'm not sure if they will provide the slides. I hope so. If not, you have to ping me. The best would be on LinkedIn, and I can provide you the slides. I don't have them online because I change them all the time. But this study is publicly available, quite interesting. And then there's a dissertation where the guy figured out that every 100,000 lines of code that a company owns in their software costs them around 361,000 in technical debt, which is a lot. I mean, if you work in a bigger company or in a bank or insurance company, they have huge code bases. So you get an idea about the cost of this stuff. And you can also figure that out. I'm not sure if you can access it because I saw it's publicly available for free, I think, in September this year. But there are ways to get this dissertation. Okay. So we have two types of bad code. Legacy code, dead code. Let's take a look at legacy code. Probably all of you stumbled upon that in your career. So usually this is code that was written for no longer supported operating systems, hardwares, APIs, or whatever. And it's most of the times you cannot test it automatically, and usually there are no tests at all for this kind of code. And it's no longer developed by the maintainer, right? Or nobody at all. So it's just code that sticks in your code base. It works. Nobody has any idea because it was created way before you joined the company sometimes. And yeah, so nobody is really developing it or maintaining it. And it has no documentation usually, which makes it even harder. In short, it's code that you are afraid to touch because, yeah, it's working. I have no idea what it does. It was there when I joined the company. We keep it, okay? Just don't touch it, it works. So, why still using it, right? Because, as already mentioned, it works most of the time. There's no replacement available. Sometimes there's code that you can't simply replace. And then nobody's able to understand it, especially if you have in banks and insurance companies, we saw that. So I also worked as a consultant in Switzerland and in Singapore. And I saw that in banks specifically, they have huge code bases, and then you have this code and you have really no idea what it does. It works, but how? No clue. Yeah, and the other thing is no one knows if it's still in use at all. Because you have this code. It was there when I came. I guess it's used somewhere. Not sure. We leave it in, just to make sure, okay? So how to handle these situations? So usually you can do refactoring. You can rewrite everything. Sometimes it's a good idea to do that, but yeah, there are some drawbacks with that. You can find out if it's used at all and then remove it. That's the tricky part. So refactoring, we all know that. So you need to understand the code first to be able to refactor it, and that takes some time. You can make use of static code analysis tools. You will find stuff like checkstyle, spotbugs, PND, SonarCube. There are lots of tools that can help you with that. The most important part, you need the time. And usually we don't have the time to do that. Because if you talk to your manager and say, yeah, I saw this part of the code, I would like to refactor it, and then they say, no, just do this because we have this project. We have to finish that first. And maybe next week. It means never, right? So you can rewrite, which is more or less, or which is even worse, right? So because again, first of all, you have to understand what the code does that you would like to rewrite. And then in principle, it's like a new project. And that means with all the cost that is involved, you start from scratch. And the other thing is you need to know the requirements that have been used when this project was implemented. And this is sometimes hard to figure out because the people that defined these requirements are not in the company anymore. So you have no idea. So you really start from scratch and takes a lot of time to do that. So usually nobody does it. One question remains, is it used at all? Because this is something you have no idea. That leads me to dead code. And it's a little bit tricky with all these definitions because they are not really sharp and not widely used. So when I say dead code, then I mean code that is unused imports, variables, methods, classes that stick in your code, and they are simply, for example, not reachable, right? Or they will never be called by your code. So you have some methods and you're afraid to remove them, you just leave them in. Because maybe you use them in the future, right? Or maybe you are afraid to forget how the code worked because you had such a good flow, you implemented that code, it's beautiful, I can't remove it, I just keep it, right? But it's not reachable, for example, or it's redundant. So you have the same, and I saw that also in banks. So you have one project, it's done by a consultancy company. They implement this and they add lots of functions. And then in its functions or methods, they do some stuff. And you have another project done by someone else, does exactly the same. The methods have different names, but the functionality is the same. So in principle, you could keep just one to get rid of the rest, but not so easy. So why is it a problem? Well, we have different points. Why is it a problem? So first of all, it clutters the code base. It reduces the readability, the maintainability, and it makes it really hard for developers to get a clue what's going on in that code if you have all these things that are really not used. It increases the file size. That wasn't a big problem in the past where we had application servers. They have been big. But today we have microservices. Usually I now ask who works with microservices, and I can't really see anyone, but I guess probably a lot of you. And we see with cloud cost, containers have to be small. Also for the DevOps people, they would like to have small containers for deployment because also the size of the containers needs more time to upload, costs more money to deploy that to the cloud. And so this is something, if you have stuff in there that's not needed, why? Yeah, it would be good to get rid of that. It's a potential for bugs, so you can have code that is dead, but it contains bugs, and programs will find that. So if you have something like spot bugs and stuff, that will find the code, and you have no idea. Oh, there's a problem, but what is it doing? I don't know, because I don't know if it's called or if it's used at all. So you have to figure that out. Security, another issue. So if you have methods in your code that are vulnerable or potentially vulnerable, but they are dead, that means maybe they are not reachable at all. So why keep that stuff, right? So this is also why it is a problem. And where does it come from? I mean, yeah, we know that. Rapid development iterations, build now, fix later, right? This is the biggest problem that I see because I saw that in many projects. The hesitance to delete stuff, and I find myself doing the same thing. So I've wrote a couple of libraries and I add this code because I think, yeah, this is great. I can use that later on. And then I never use it. So it's there, but I don't use it really. And then I don't want to delete it because I like the method. It's so great. Instead of putting it somewhere else, I just keep it in that code. So that's, I don't know. I might be able to see, but who knows that problem? Hesitance to remove it. Yeah, this is something, it's your baby, right? So you wrote that code. I love it. I would like to keep it there. I don't want to remove it. And for me, it's mainly because I'm afraid that I forgot how it works in the future. And if I need it again, then I know where to look for, which is the wrong approach, but this is how it works. Incomplete prefactoring, yeah, this sometimes can happen. So that's well known. Merging code branches is also one of the problems. If you merge stuff, then suddenly you get stuff from the other branch in your code, and you have no idea because it was not written by you, and who is really checking after a merge if the code is really doing everything you need to know. It works. All tests are green, great. But you might also have added some code that is not used, and you are not aware. Lack of awareness, yeah, of course. If you're in huge projects, and I don't say that is easy, but especially when I was in Singapore in that project, that was DBS, which is a huge bank. The code base is massive, and there's so many side projects. Of course, not one developer can have a clue what's going on in all these projects. It's just too much. And that leads to this fact that we create that code. So how to remove it? There are easy ways, and we know that. Who's using IntelliJ? I will try to see that. A couple of people, right? And other IDEs can do the same. So there's an easy way. If you have this kind of code, and I have, for example, method 3, it's not used, and I have this variable temp, which is also not used, then IntelliJ it will also directly show it in the code by graying it out if you have enabled it. But if you would do it from the menu, then you just go from code, analyze code, run inspection, unused declaration, and then you find something like that. It will show you, oh, you have this variable, you have this method in that class, and then you can remove it. But you have to do it. This is one class. Okay, if you have a huge code base, that takes forever to do that. But at least you can do it. SonarCube IDE, I think it was called SonarLink before. Very much the same, a little bit more flexible. You can configure exactly what kind of code it should look for. And then this is all the checkboxes that you see there. And then again, you run it, and it shows you, okay, you have this method, you have this variable, and then you can remove it. Okay, that's all cool, easy. But still, you have to do it manually. Takes some time. So a different approach is, and SonarCube, if you don't know it, you can get it here, and you can even use it for free, parts of it in the IDE, and it's a good tool. But a new thing is Open Rewrite. Who knows Open Rewrite? For those people who don't know, it's pretty cool. So it's a community-driven open source project from Modern, and it enables developers to effectively eliminate technical debt so they can modify your source code based on recipes. And that's pretty cool. So they have an auto-refactoring engine, and these recipes, you can either take already existing ones or you can create your own. And you can, for example, I have an example that removes methods. So again, I have this method 3, which is not used at all. Let's think about it. I have a REST endpoint. I have multiple methods in this controller, but this one is never called. So we would like to get rid of it. Then we add this to the dependencies in Maven. It could also be Gradle, it doesn't matter. And you see I add the plugin, Open Rewrite Maven, and then I can add active recipes. And in this case, I added the remove unused private methods recipe. So when I run then mvn rewrite run, this is the code before that. After I run it, gone. And this is just a very simple example. They can do way more. And that takes away the burden that you have to go to the code and delete manually all this stuff. So they can do that for you. This could even be a part of your build process, right, in CI/CD. So to clean it up before you build it, really. Very nice tool. Okay, that's all good. You can find it here. It's on GitHub, github.com/openrewrite. Check it out if you don't know it. It's quite cool. It takes some time to get into it, but it's great. So the company is quite young, and this product, but it's really good stuff. Okay. But what about, now we saw dead code, stuff that is not called in your code base. What about zombie code? Does someone know what zombie code is? Ever heard of it? Yeah, that's interesting. And that's what I meant with all these different definitions that are floating around. So dead code was stuff that is in your code base, and the IDE can figure out, oh, all of your code is really never calling this method. You can get rid of it, okay? But what about code where you have tests for the methods and classes? And so it is maintained, it is deployed to production, but in production it's never executed, right? So first of all, you think, yeah, how much could that be? So let me tell you, we have a customer, and I was surprised when I saw the numbers. They ran the tool and checked it out, and they figured out they had more than 50% of the code was never called. So they deployed all that stuff to production and thought it is used, and it was not. So how can that happen? So for example, like I said, you have a REST endpoint, or you have multiple REST endpoints. Because you added them, because it was part of a project in the past, so it's still in this controller. But in fact, your UI for the customer never calls it, or customer itself never used this method. So it's just there, but it's never called, right? So this is zombie code. Or the worst thing is, the only code that calls this method is your test. That means the IDE won't find it, because oh yeah, it's called, no, it's all good. It's not dead. Well, yeah, it's called by the test, right? And this is the worst thing that can happen. And we saw that really a lot, which was surprising, even for the developers specifically, because they thought, oh, we haven't been aware of this problem, right? So the problem is how to find this code. How to find code that is in there, you have tests, but it's never called in production, right? You can only do that in the running system. That means at runtime, in production, you somehow have to find a way to find these things that not have been called. So and there are different approaches how to do that. So the first thing is tombstone logging. Did someone ever heard about it? It's a pretty simple approach. It works. You will get it. You use static initializers in classes. I don't know if you know what it is. We will see that. And you can use, for example, custom log levels, right, for log4j. I have an example with log4j. That means if we use log4j and we have the configuration, I can define my own log levels here. Like I created one for used class and used method, okay? And then you can add appenders, like I would like to see it on the console in this case. And then you can also add some configuration for the appenders, for the logger. This is just the configuration for log4j if you would like to have custom log levels. And then in the code, this is my class. I have my logger object there, right? And then this is a static initializer. Whenever you create an instance of this object, it will call this method, right? This static initializer here. And in this case, I log used class, right? So I will get this information in the log file every time I create an instance of this method. And for the method itself, this is the code that is running, okay? So you see I call method 1, 2, and 4. Method 3 I never call. And then the code for that is, in these methods, I do the log of each method. I use log level used method, and then add the stuff that I would like to see in the log output. And method 3 won't be called in this case. Here, this is maybe a bad example because the IDE will figure that out because, oh, this method was never called. But this could be, like I said, a REST endpoint, and then this is covered by your test, so you don't know if it's called in production or not. But you can now run the code, and then you see the log file, and then after some time you will find all the stuff that was called, right? So you see, oh, this class was called, the method 1 was called, and so on. Method 3 was never called in production at runtime. Therefore, you have to check the log file. And you can imagine if you have to add that to all the methods and all the classes in your code base, that's a lot of work. You can do that automatically, but still, it's a lot. And then you have to think about the log file that you create, because afterwards you have to parse the log file and find all these classes. And there's another point, because you get the used classes and the used methods, you don't get the unused stuff. That means you have to figure out a way to find what is in the jar file, which classes, which methods, what was called, and then you have to make a diff, and then you find the stuff that wasn't called, right? It is possible. It's a lot of work. But at least it's possible. And then flight recorder. Who knows flight recorder? Just a few. Oh, you should know that. This is good stuff. Flight recorder and mission control. So flight recorder makes it's similar to like logging, but you can get more information. And it's really made without adding a lot of overhead. So you can create custom events, and then flight recorder will fire events at runtime. And then later on, you can use mission control to take a look at these events and filter them and all these kind of things. It's quite useful. So in this case, I create custom flight recorder events and then afterwards use mission control to analyze the data. It's very similar to the tombstone logging. I have my events here, so this is the way you define it. This is very basic, right? It can be way more complex, but this is, for this case, it's totally enough. So I have a used class event, I have a used method event, and then you can already guess in the code I do exactly the same that we saw before with the logging. I use a static initializer, then I fire the used class event, and in the methods, instead of logging, I just fire the flight recorder events. Okay, that's easy peasy. That's the same as with the logging, and also with the results, we see the same. So that might be hard to read. It's not that important, but this is mission control. And then you can get the flight recorder logs, right? And then you can see, oh, there have been some events. This is, for example, the used class events. There was only one, and then you see this is the used method events, and then you see, oh, this has been the method, have been the methods that have been called, and you will miss method 3. It's not in there. Okay. So the result is very much the same that we saw with the logging, but you have more tools to figure that out and filter it, and you can search in that. So it's more powerful. Okay, but again, you only get the information about the used code, not about the unused code. So it's up to you to figure out a way, how can I create that diff between used and unused, right? Or better to say, between all code and the used code. So that's good tools, but a lot of work. Is someone doing that kind of stuff, maybe? The logging? Yeah, okay, that's cool. Because it works. I mean, you can do that with the stuff that comes with Java, right? So it's a lot of work, but if you start a new project, you can use this technology to just use, to figure out what code is used or not. Okay, other solutions. Who knows Jacoco? You should know it. Java code coverage tool. I think it's more or less the Java code coverage tool. And I have an example for Open Rewrite with Intelligence Cloud. We will see that. Okay, Jacoco, like I mentioned, Java code coverage. It's a free tool to report code coverage on automated test suites. And it collects coverage metrics through a Java agent when the class loader loads classes. So we will take a look at Java agents shortly. So for those people that have no idea what a Java agent is or what it does, and then you understand how it works. And then it's usually used in development, so you don't use that in production. One of the reasons is that if you use an agent, and I will explain why that is a problem, then it comes always with a performance overhead, more or less. And you can use it to detect that, or in this case, zombie code, which is unexpected, to be honest. It's just a smart move. Java agent, so who knows what a Java agent is? Okay, just a few. Let me explain it to you. This is the JVM, like a black box. Of course it's not. It has different systems, like it has the class loader subsystem, it has the JVM memory system, and it has the execution engine. And in this, you will find stuff like the compilers and all these things. So each JVM that is based on OpenJDK also has an API, right? It has the so-called instrumentation API. And that means if your application is running in the JVM, you can talk to the JVM at runtime. And for that, you use a Java agent. And the Java agent is also, it's a Java program that it goes to the instrumentation API, and then it sets up callbacks into the JVM. So in this example for Jacoco, they add callbacks to the class loader subsystem. And every time the JVM loads a class, it will trigger the callback and tell the agent, oh, I loaded this class, by the way, right? And it will do more, right? Because Jacoco needs more stuff. And that's exactly the problem, because if you do that at runtime, then the JVM, first of all, has to run your code, and at the same time, it has to always tell the agent what it does. And that is an overhead. And it depends on how much stuff the JVM has to tell the agent, it can bring down the performance. And it's, again, something people are hesitating to use in production because you don't really want to bring down performance in production. But this is how Java agents work, in principle. So then how to find zombie code using Jacoco? So you have your jar file, which is your application, and then you deploy it in the JVM. The JVM starts running the code. Then you attach the agent to the JVM, right, to the API. And you have to make sure that in Jacoco you can specify the packages Jacoco should monitor. And this is because if we monitor everything, we will bring down the performance of the application. If we just say, I'm not interested in code that is not used in Spring Boot, right, because I can't change it anyway. But I'm interested in the code that I wrote, so just look at the packages that I wrote, right? So that is way smaller, and then the overhead is smaller. So then the agent will forward this information into Jacoco. And after some time, and some time means months, right? Because, for example, if you run in a bank, you have lots of jobs that will only be executed once a year. So that means just because something wasn't called in 1 month, you can't just simply delete it, right? Otherwise, the next time it will be used, like, oh, where's the code? So you have to be careful with this kind of stuff. But we do that, let's say, for 6 months. And then we use Jacoco CLI to gather the data. That means there's some kind of commands that you can trigger in Jacoco to create some binary data file from the data that it collected over the time. And then you use, again, the CLI and pass the class files and the Java files to Jacoco. And this is the specific step that was needed to figure out this is all the code, right? We pass all the code that we have to Jacoco, and it knows the stuff that was called. And then it can do the diff by creating a report, and then you can take the report where you have the diff, and the report, it's a kind of work that you have to do. And then you can use the report, and it will tell you, okay, this code was used, this was not used, and then you can remove the code that wasn't used, right? Okay. There are 2 blog posts that are quite interesting that use this approach. This one is a little bit older, but it's quite interesting if you work with a monolith, like an application server, because this guy figured out how to do it, how to use Jacoco to find zombie code in your application server that is running. And if you follow the QR code, then you can read about it, how he set it up and all these kind of things. That's okay, but these days we use microservices, right? We have containers, Kubernetes, and all these things. So it doesn't really help, right? Because it's an application server. So there's another company called Picnic in Europe, and they wrote a blog post and they show how to use it in Kubernetes, how they did it. Just be aware, it's still a lot of work, because in the end you have to remove the code manually. That's still the point, right? So it helps you to find it if you use their approach. And then you also have to write some code for the report and all that. But in the end, you can find that zombie code and you have to remove it manually. Okay, but this is possible. It's quite an interesting blog post. And I think it's from last year or the year before. So it's recent. So it's not very old. Right. Jacoco, if you don't know it, look it up here. It's also free available on GitHub. And you can play around with it. It's a good tool. Right, so then that leads me to the next point, which is also the last one of this presentation. It's an open rewrite and Azure Intelligence Cloud, because we saw that problem with customers. And to be honest, it wasn't really us that had the idea, but customers came to us and said, you know, you have this thing like Intelligence Cloud. Can you use it and tell us the code that is not used? And then we thought, yeah, we can do that, right? So to give you an idea, Intelligence Cloud is a service, it's a cloud service, and it can collect data from JVMs, from any JVM you like. And we also use an agent to do that. But this agent is very minimized because it gets only the information that we need about the methods and classes that have been called. So this will even work on all packages in your code base. And it offers information about used and unused code in production, which is fine. How to find zombie code with this one. Pretty much the same as we saw with Jacoco. So you have your jar file, but with this approach, you can run multiple JVMs, right? Like say in a cluster, no problem. you attach the agent to all of these JVMs. And this can be done automatically, so you don't really have to take care about it. This can be done by just adding an environment variable, and then this will automatically start the agent. And now the tricky or the good part that we have that makes it different is all these agents will talk to one forwarder. And this forwarder can be installed by your infrastructure team somewhere in your infrastructure. It just has to be reachable from the inside. And the agents tag your application, because this one, the lower one, could be the same application running on an ARM instance. The middle one can run on an Intel instance. Doesn't matter. It's the same application. But because we use the same tag, in this case, for example, my app version 1, all these informations are tagged with the same tag. Later on in Intelligence Cloud, we can just filter for the tag and it will give us all the data it finds for this tag. And this makes it possible that even if you run it in a cluster, it doesn't matter. Because if you tag it, then you can filter by tag, and then you will find the same application for the same time frame. And then the forwarder will then forward the information to Intelligence Cloud. The difference here is that the agent's not really pinging all the time, because the JVM will collect data and will just send it over to the agent from time to time. So we don't see any overhead here. It's below 1%, so it's nothing. In production, you can easily use that. So then, again, run it for 6 months or later or longer, depends. And then you use the API that Intelligence Cloud offers. You can write your own client tool and get a report about used or unused code. So I did that to figure out how it works. This is what I created. So it's very much, because I'm also a developer, it very much looks like the stuff that you know from your IDE. You see this tree with the packages, and then you see the classes, and you see the methods, and then I can tell you if the method was called or not, and have some diagrams that show you, okay, in this package, 76% of this package was used, or 36% of the classes have been used, and all these kind of things, right? I can also filter for unused classes. Again, I can create a report, and then I have to do it manually. Oh, okay. So it seems we don't get around this point removing stuff manually, but remember that I showed you the open rewrite thing. And we worked with them together, and that's the new thing, which is really interesting, because now what we can do, you can use open rewrite, and it will access Intelligence Cloud, right? Get the information from let's say you monitor the last 6 months. So it gets this information and can analyze it, and then, and this is now the beauty, it will annotate your code. So it will find all the unused code and will add annotations to it. So in your code base, suddenly you see something like deprecated since blah, 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 for removal equals false. It's just an annotation, and that's it. And now, because I told you, if you run something in banks or insurance companies where they have these yearly jobs, they only run once a year, we need more time, right? So that means we have a second step, maybe 3-6 months later, whatever. And then again, we check what was used and not used in this time frame. And we can either, if the code that was annotated, deprecated before was called in the meantime, we can remove the annotation again. If it's still not used, we can change the for removal from false to true. And of course, we can also add new annotations. And then in the third step, which is then the final one, which again could be another 3 months, we can remove stuff automatically from your code base, right? Of course, you have to be careful. So I don't say just trust it, believe it, and away. It takes time, as mentioned, a year probably before you can really remove code. So it's not a short-term process, but it can really help to reduce your code base a lot, because it can really automatically remove stuff that is never called in production, actually, which is quite interesting. So what you get the ability to find used, unused code in your running application. It creates reports at any time. So you can, in Intelligence Cloud, you can always go in there and say, tell me if the code was used in that time frame from A to B, whatever it is. And then it will tell you. You can filter by these tags and stuff. You can run it on multiple JVMs at the same time, different architectures, no problem. It offers an integration API for other tools, and you can annotate, remove unused code automatically using Open Rewrite, and this is pretty cool. It's not there yet, so we are working with them together, but this is, it will come in the near future. So we have some first working prototypes of this, but that means the whole process could be more or less automated in your CI/CD build process. If you would like to have more info about it, you can find it here on our homepage. And I hope, I can't promise, but I hope that we will be able to have free testing periods where you can play around with it, because it comes with other stuff like in production vulnerability scanning and all these kinds of things. All right, conclusion. So zombie code is real, right? So like I said, I can't tell you the name, but we went to a company, they pinged us and then said, oh, we are interested in this tool, can you show it to us? We showed it to them. We ran the proof of concept, and then it turned out that more than 50% of the code that they deployed was never called. And that was for them quite shocking, right? Of course. So the stuff is there, we just don't know it. Monitoring takes time. This is probably the bad part of it, because it's nothing that you can convince your boss, like, yeah, I saw that, it's cool, you just run it a week and then we can remove code. No. It really takes probably a year before you really can start removing stuff to make sure that it's really code that is not used or not called. Setup and reporting is challenging, so it's not that easy. If you use these other tools like Jacogo, which is also great, it works. But again, like I said, it takes a lot of time to create this stuff. Once you have the process running, it's good, but still you have to remove code manually. So it all depends on the size of your code base. If you're a small company, you probably don't need this. Then you can use Jacogo or the logging stuff. If you work in, like I said, banks, big industrial companies, they have old code bases, this stuff really helps. Document your code, refactor regularly, and communicate with your colleagues. I found this is one of the biggest problems that since the pandemic, you don't talk to each other, right? So it's because the colleague is not there. If you're in the office, at least I know it like that, it's quite often that you talk about code, you talk about problems that you saw. That doesn't happen these days, which is also a problem. So just try to do that. Yeah, and use tools like Jacogo or Open Rewrite with Intelligence Cloud, because it really can help reduce these problems with zombie code. And that's it. And I think we are good on time, because this is usually for 45 minutes. I think we have 60 here. If you have questions, we have lots of time. If you don't have questions, then you have more time for the conference. So, any questions?
What about UI thing like, Vue.js, JavaScript?
Okay. No, this is not, because we don't know. This is just because it's based on the JVM. So the question was, what about UI stuff? Like if you have a front end written in JavaScript, can you also tell us what code is coded in there? No, we can't. The reason is that this is all based on the problem that we try to solve, is all based on the JVM. So the JVM is running your code on the back end, and we monitor it using the agent. What is going on the front end, we don't know, because these are clients running somewhere. They work with your back end, right? So we can't really tell you. We only can see what they call and not call in the back end, and that tell you what was called or not called on the back end. I'm not sure if there's something on the front end, because that would mean it has to be in the client. And then the client has to talk to some central place to tell your application or the application owners if it was used or not. So no, this is only for the JVM. So everything that runs on the JVM is fine. It could be Kotlin, it could be JRuby, whatever runs on the JVM we can monitor. But if it's outside, then we can't. Sorry. Any other question?
Does this article that you referenced, does it kind of go into detail how you created the Java agents and changed all that stuff?
You mean the one, so the question is if the article, I guess the Jacogo one?
What is this one on the Intelligence Cloud?
Our Intelligence Cloud, we don't have an article yet, so this is only on the website. But if you use Jacogo, then the blog post that I showed you, they go partly into detail. So they I think they have parts of the code even available for testing, but the reporting part, they don't have. So this is the hard thing, right? You get the information that was used, you get the information that was not used, but then you have to merge it somehow. You have to find out the diff, and then you have to create the report yourself, and then it's work. It's not that easy. But it's possible. So they show that it's in use in Picnic. And Picnic is not that small. So they're quite young, but they're already quite big. It's then kind of a food delivery service in Europe. Any other question? Yeah?
You said that there's complexity in setting the cloud service up on containers, right? What kind of complexities are involved?
Sorry, I didn't get it. Can you repeat it?
What kind of complexities are involved in setting up the agent? Like you mentioned.
Oh, setting up the agent. Oh, the question is what kind of problems or work is involved in setting up the agent? That's pretty simple, because that was when I saw that, when we came up with this tool with Intelligence Cloud, and this also applies to Jacoco, I was like, yeah, that's nice, but you have to start the agent. How can you make sure, let's say you have a big insurance company, right? And you would like to figure out what code is used. That means everywhere where you would like to use it, you have to install the agent to make it work. Installing the agent means just it's a jar file, copy it on the machine. This is easy, because usually the infrastructure team can do that. Making sure that the agent is started, this is the harder part. But that's what I didn't know at that point. The JVM comes with some features, and one of these features is if you add a specific environment variable to this machine, it will, every time you start a JVM, doesn't matter which one, it will start the agent automatically. And that makes it quite easy, because setting environment variables remotely is also part of the infrastructure team. They can do that. In big companies, this is their normal job, right? So that means setting up something like this in a bigger company isn't really hard. I was also surprised. The bigger problem might be the forwarder, because in this case, it has to be in the demilitarized zone somewhere in your company. So because the forwarder talks to the cloud outside. And it's a one-way thing, right? So you can't really talk to the forwarder from the outside, but you have to talk to the forwarder from the inside. Every agent will contact it, and then the forwarder will forward the information to the cloud. This is sometimes the bigger problem, because then it's like, oh, we have to open a port to let the forwarder talk to the cloud. But the agents itself, it's not really turned out that was the more or less easy part, because we just copied the jar file on the machine, and we started by switching on the environment variable, and then that's done. Everything you need to do is this 2 steps. Any other question? Yes?
Yeah. I've got one that somewhat relates to that, and that is, like obviously what you're talking about is a cloud solution.
Mm-hmm.
Is there any hope ever that there might be an on-prem equivalent solution?
Yeah, the question is if there would be the chance that it's not in the cloud but on-prem, because then you can host it yourself, right? We're working on that. The problem is that the whole intelligence cloud stuff that we do is all based on AWS at the moment. And we use functions that are only available in AWS, and we are trying to get rid of this stuff to make it, first of all, more cloud agnostic, so that it can run on all clouds. And that would also make it possible, I can't promise when, but we see that problem. So we see that there are some companies, specifically in the security area, right, or military, they don't want to run this stuff in the cloud. They would like to have it in their own data center. And we are working on that, but this is just on the bucket list, that's all. It's not really something that I can promise that will come in the near future. Any other question? If not, then enjoy the rest of the conference, and thanks for attending.